Okay.
Now I can say it.
Okay. So we are in the program of data science. Let me quickly walk you through with the overall syllabus, and then we will get into this program. Okay. Can you see the screen?
It's coming from.
Yeah, so,
Yes, we can say it.
Okay, what is the screen you are seeing? Like, it's a whiteboard or it's a browser?
Whiteboard.
Okay. 1 second. So how many of you have earlier worked on big data, Hadoop or Cloudera?
I worked on it.
Okay. I'm just opening the. Okay. So let me walk through the program first, and then we will get into each and every model. Okay. So we have total program time, which is 30 hours. I think most of you know about this, right? So this is a 30 hours program. 30 hours. Okay. And we have 5 models in our program. Okay. So this is 30-hour program, and we have 5 core models as part of this program. Okay. So, and typically we are calling this in a high level data science with Python, because we are going to do all our data analytics and data science work using a programming language called as Python. So that's why we call this program as a data science with Python. So how many of you have worked in Python earlier? Okay, so how many of you worked on data science earlier? Sorry, Python. How many of you know Python?
I learned the Python a little bit, so I know basics.
Okay, so in this program, Python is going to be a core thing. So I will be covering Python. Okay, so you don't need to worry about it, but Python is going to be a core part in the data analytics or data science. Okay. Okay, so let's move on to the different models we have in our program. So the first model. So I'm just trying to give you the overall program roadmap. Okay, so that way you will have a clear picture. Okay, so in model 1 we are going to talk about Python. So how we are going to use Python to control and document data science process. So before that, I will walk, because that is not part. In this model, I will be starting with Python programming first. And then we'll talk about how we can control and document our data science. Control and document data science. So in Python programming, we will be talking about all the key concepts that we have with Python. So we will talk about basics of Python, programming like loop statement, how to write a program, how to compile, and how to see the output. And then we will talk about how we can leverage Python to analyze and to drill down into data to get and to extract our required data. Okay, so in model 1 we will be mainly talking about Python programming, and we will be talking about how we can control and document the data science. Clear? And under this we have different sub models. Okay, so we have different sub models. Let me put one by one. So we'll talk about data types and objects. So this is more about Python. So we'll talk about Python, different type of data types and objects. And then we'll talk about packages, namespace, and then how to read and write data. Because when we want to perform any stuff on the data, so we need to first read, or we need to save it before we process on the data. So we'll be talking about how we can read and write data. And then we'll talk about different types of plotting. So there are different ways through which we can plot the data in a visual view. So for that we are going to talk about different types of plotting mechanism. And then we will talk about control flow. And then we will see how to debug Python programming. And then finally we'll talk about code profiling. Does that make sense? So in model 1, we will focus more on Python programming. Under that, we will talk more in detail about data types and its corresponding objects. And we'll talk about package, namespace. And then we'll talk about how we can read and write data to different like mechanism. So we can store the data in a raw file. We can store the data in a relational database, right? So we'll talk about different mechanisms, how we can write and read the data. And then we'll talk about plotting the data in a graph. And then we'll talk about different controlled flow statements like if, else, and then for loop, while loop, all those stuff. And then we'll talk about how we can debug the Python program, right? Because if we want to debug any issues, or if you want to debug how the process flows, so for that we need to know how we can debug Python program. And then we'll talk about code profiling, how to profile the code. So these are all the topics that we are going to talk in model 1. So any questions or any queries in model 1? Guys, can you say yes or no?
No.
Are we clear with model 1? Because see, the thing is, we are talking about the roadmap. So the roadmap is very, very important so that we can synthesize whenever we are covering that topic. So please make sure that we have clear understanding what is the program, what are all the different models that we have in the program, and what all the topics that we are going to cover in the program. So that will give you, clear path and how we are going to travel in the program. Make sense? And guys, please be more interactive. So this should be more interactive session, because I don't want to be, kind of one-way communication.
See,
Yeah.
there's a problem with this whole thing because I joined to a computer and to a phone, rather than to a phone. So I had to unmute myself in two different places. So that takes like a good amount of time.
Okay. But one thing I want to
And
highlight.
some people are typing the messages in the chat, so you want to keep an eye on the chat as well.
Okay, sounds great. Yeah, but please be more interactive. Let's explore things, and let's have a kind of more healthy discussions that will make us explore more things in real time. Okay, so let's be more interactive. And then this is about model 1, and then model 2. So in model 2, we are going to talk about how to access and prepare data. So model 2 is more about how to prepare data and how to access data. Prepare and access data. So in this Okay, let's start here. Let's start here. Okay, so in this we are going to talk about how we can load and how we can access data from different sources. So in this we are going to cover commas separated CSV files, and then we'll talk about SQL. So this will help us how we can extract data from different data sources. Okay, and then we will be talking about cleansing data with Python. So the next core thing that we'll discuss in this model is cleansing data with Python. So in this, we'll be talking about how we can stripe out extra information, how we can normalize data, how we can format. This is more about striping the required things like striping extra data, and then how we can format data, and then we will talk about how we can normalize. I think you may hear about this normalize and denormalizing the data. Normalizing data. So this will be covered in the model 2. So in model 1 we will be focused more on the Python program, and in model 2 we will be focused more on how we can access data from different data sources like CSV and SQL, and then we'll be talking about cleansing of data with Python. So in that we'll be talking about how we can stripe out extra information that we don't need, and then we'll talk about how we can format the data and how we can normalize and denormalize the data. So that will be covered in the model 3. Sorry, model 2. Any questions? Guys, any questions, any queries in model 3, 2 and 1?
With regard to unstructured data, you didn't talk on this one.
Unstructured data, we can cover that in, I think I have specified only CSV and SQL, but we'll talk about raw data, meaning how we can like I think as you said, Sharma, we have 3 types of data, right, just to cover. So we have structured, semi-structured and unstructured data, right? So in structured we are covering SQL. For unstructured you have the text or raw files, and then in semi-structured we have XML and JSON. So we'll cover all the 3 kinds of data in model 2.
Okay.
Make sense?
Okay.
Perfect. And then model 3. So in model 3 we are going to do some analytical algorithms. Okay, so in that we will be covering the first one is numerical analysis. And the second one is we'll be talking about data exploration. And then we will be talking about data visualization. So in model 3 we are going to focus more on numerical analysis, data exploration and data visualization, and we are going to do this stuff using 2 key algorithms. Okay, one is NumPy arrays and matplotlib. So we are going to do this using NumPy arrays and I don't know, for some reason I'm not able to go down. Okay.
Okay, that's because it almost reached the bottom of our screen or viewing area. So you may want to take this out because there is some space on the top.
Sorry?
Even we are watching your whiteboard, so you are already in the bottom of the screen.
Oh, okay.
There is a lot of space left on the top of the screen.
Oh, really?
These things on the top will get more space.
Okay, I will do one thing. I will erase. Okay. And then text. Let me start again. Okay. So in model 3, we are talking about data exploration, data visualization, and numerical analysis, right? We are going to do that using two things. One is NumPy array, and the other one is matplotlib. NumPy arrays and matplotlib. These are libraries. So we are going to do the data exploration, data visualization, and numerical analysis using these libraries. Okay, so these are the libraries which are provided to perform these operations. So in this, we will be covering, first of all, we need to understand what is NumPy array, right? So we'll be talking about what is NumPy array. And then we will talk about 2D plotting, how to do a 2D plotting with matplot library. 2D sorry guys, I'm very new to this whiteboard because I used to have text edit as my whiteboard. This is the first time I'm using this whiteboard tool from Zoom. That's why I'm a little bit struggling. So this will be solved. So matplot library. So first we'll talk about NumPy array, and then we will be talking about 2D plotting with matplot library, and then we will talk about n-dimensional array and manipulation. N-dimensional array operations and manipulations. And then we will talk about memory map files. Memory mapped files. So in model 3, we are going to talk about numeric analysis, data exploration, and data visualization. For that, we are going to use NumPy array and matplot library. Under that, we will be talking about what is NumPy array, how we can do 2D plotting with matplotlib, and then we'll talk about n-dimensional array operations and manipulations, and then we will be talking about memory map files. Okay, so these are all the topics that we are going to cover in model 3. Any questions in model 1, 2, and 3? Guys, can you say yes or no?
You don't have any business intelligence, adding business intelligence or manipulating the data with kind of intelligence adding kind of a thing. Like let's say you have some kind of a data coming in, and based on current data or predictive analysis kind of a thing. Can you do this?
So are we talking about the machine learning with the data intelligence?
With intelligence, in fact, with artificial intelligence or machine learning, or adding business intelligence kind of a thing. Basically, like any business will do that, right? Yeah.
Yeah, that we will be. Yeah.
Artificial intelligence and machine learning both together.
Yeah, so we have that covered in model 5.
Okay. Right.
Okay. We have a model 5 which talks about machine learning with scikit-learn. So where we will be covering all the business intelligence and machine learning, all those stuff. Data mainly business and data intelligence. Okay. Okay. Next one is we are going to talk about model 4. In model 4, we are going to talk about two key things: how we can explore data. So it is more about data exploration again. So we can say data exploration. So we are going to do the data exploration using two key algorithms or framework or library, we can say. One is pandas, and the second one is SkyPy. Sorry. SkyPy.stats. Okay, so model 4 is more about data exploration. So we are going to explore the data using pandas and SkyPy.stats. So in this, we'll be talking about how, let's talk one by one. So first we'll be talking about data manipulation with pandas. Second one is statistical analysis with pandas. Things done. I need to go down. And the third one is time series analysis with pandas. And the last one, we'll be talking about how we can do a statistical analysis using the statistical tool called as SkyPy.stats, which is a statistical tool. Clear? Any questions in model 4? So in model 4, we will be talking about data exploration. Under that, we have two key frameworks. One is pandas and the other one is SkyPy.stats. So we'll be talking about data manipulation with pandas and statistical analysis with pandas. And then how we can do a time series analysis with pandas. And then finally, we'll talk about SkyPy.stats, which is a statistical tool. Clear? Any questions on model 1, 2, 3, and 4? Okay. Shall we move on?
Just a quick thing. What is pandas here?
Pandas is a library. So we are going to use that library to manipulate and do some statistical analysis and time series analysis with the tool or framework or library. It is a library.
Okay.
Okay. So the last model is model 5. In model 5, it's more about machine learning and business intelligence. So in this, we are going to do this using a library called as Skykit. So Skykit is a tool or a framework. Using that, we can do a machine learning and business intelligence. So in this, we are going to cover the first topic would be input. How we can do a input using 2D samples and features. So this is the first topic. This is more about how to feed the input. And the second one is how we can pre-process data. So this will be the second topic, which is pre-processing the data. And the third one is regression, classification, and then model selection. So this will be covered in the machine learning and business intelligence. So we are going to do machine learning and business intelligence using this SkyKit tool. For that, first we will be talk about how we can feed the input. So the input can be fed as a 2D samples of features, and then we will talk about how we can pre-process the data, and then how we can apply regression on the data, and then how we can classify the data, and finally how we can do a model selection. Clear? Any questions? Any queries? Guys, any questions before we move on to the exploration on each and every model in detail? So these are all the overall models that we're going to cover, and these are all the topics that we are going to discuss. We can say this is our roadmap. Any questions?
We're okay, Commission.
Okay, shall we move on?
Sure.
Okay. Let me erase. Okay. Is there any way that I can maximize this? Is it full screen now? Guys, is the screen is full screen now for you? Okay.
Yeah, it's a full screen and it's black.
Put this one. I think I cannot maximize this. Okay, cool. Okay, before we get into this, we'll talk about some key topics of data science. First of all, we need to understand why data science, and then we need to understand what is data science, and then who is data scientist, and what are all the job trends. Maybe we can talk a little bit, and how we can solve the problem in data science, and what are all the different data science components we have, and what are all the data science roles we have in organization. Okay, so any of you know about these topics? Like any of you come across this stuff, like why we need data science, what is data science, who is data scientist, and how we can solve the problem using data science, all those stuff. Okay, let's get into it. So first thing is data. We are talking everything around the data. So all the organizations are storing their data for the last few years, right? So day by day the data grows, and now it becomes a huge data, correct? Because the organization keep on storing their data each and every year. So for like when we keep on accumulating the data, the size of the data become very huge, right? So meaning we are storing the data for a while, for a years, right? And this is being practiced by each and every company, right? So each and every company stores their data, right? And it becomes huge year by year, right? And sometimes what happens is after the data becomes huge, there might be a sudden data explosion will come into place, okay? Meaning data has become the most abundant thing in all the organization. If data explosion happens, that is going to be a huge problem, right? So how data science is going to play a major role in this, okay? So let's understand one simple example that we use in our day-to-day life, and then we will talk about why we need data science. So let's take an example. Let's take Apple. So Apple is manufacturing iPhone devices, and they are providing their corresponding OS for the iPhone, right? So every year they release new iPhone, and they release new iOS and with new developer features and hardware, right? How this product are being strategized and how they are creating the new phones and new OS. So it's purely based on the technology. The first thing is how we can improve the features that touches the day-to-day life of customers, and it makes things easier for the customers. So everything is customer oriented, right? So how we can improve our technology to make the customer life better, right? So that is one thing. So how we will get this information? So we'll get this information as a customer feedback, or we will get this information as a technology strategist, like how we can improve our platform, right? So two things. One is the feedback from the customer, and the second thing is how we can improve the technology from a strategistic platform, right? So when we are talking about feedback, so we have huge amount of feedback that we got from the customer, right? So we have one is customer feedback, right? And the second one is historical data points, and the third one is technology innovation. So the customer feedback and the historical data points and historical data values that we got from the customer, and the new technology that we have in the market, that leads to the next release, next generation product, right? So the next release, say for example, right now we have iPhone X or iPhone 8, 8 Plus, whatever. So maybe in the next year we may have iPhone 11 or iPhone 12. So iPhone 12 or iPhone 11, whatever new release Apple is planning, so they are going to build the next generation product based on the customer feedback and based on the data that we have from the past experience, and what is the technology innovation that happened in the current era, which may make the customer life more easier, right? So these are the data values that will make the next generation product. So in order to, so if you talk about customer feedback, this is also data. If we talk about historical data points, this is also data. And technology innovation is also a data point, correct? So all are data. So what we need to do is everything comes with data analysis and data science. So we are filtering things and making a bundle which is more value added stuff to the customer that would be taken for the next generation product, right? So data science comes with various data mining techniques, like sentiment analysis. Like sometimes customer may have a sentimental stuff, so we need to have a data point on that, right? And we will get customer feedback, and we may have customer historical data value points. So all these are mined, all these data are already stored in the organization enterprise data source, right? So we need to mine the data to filter out the key features that is going to be built as a next generation product. Guys, can you able to follow me? Guys?
Yeah, it's good so far.
And not only this, this is one key point. The other key point is when I'm making iPhone 10, I have some experience, right? So if I made iPhone X, so I have, you know, some experience that I got from the manufacturing to the customer release. Say for example, how I'm getting the raw material and how it is being manufactured and how the software is being built. So all are captured as the data points, because we can reduce our cost of product making based on the previous experience, previous exploration that we did for the iPhone X. So those data points, that is also a major key, right? So these two combinations will be get as a final release keynotes for the next generation product, right? So based on this data point, we are going to make a decision, right, which is going to reduce our production cost. So using this data, we are going to make a decision, meaning we are going to make a better decision. Okay, so this data mining decision process will make or will reduce production cost and efficiency in making the product. Clear? So with this, we can reduce the production cost and the efficiency how we can make the product. So this way we can reduce the overall price of the product to the customer. Say for example, if we sell the product for $1,000 for iPhone X, if we can reduce the say for example, if the manufacturing cost is, say I'm just giving a rough value, don't take it as a real value, okay? So if the manufacturing value is coming as 800 USD, then we are selling it as 1000 USD. It's just an assumption, okay? Don't take it as a real value. Everything is assumptional. And with the previous experience that we have the data value and data points, so we can make the production cost list. Say for example, if we are reducing the production cost as 600 USD, what we can do, we can sell the product, say for example, I will take here. So we can sell this product for 800 USD. So thereby we are reducing the overall cost of the product. Does that make sense, guys? Guys, can you say so or no?
No?
Okay, so these are some key example I'm giving. Okay, so there are countless benefits that we are gaining from the data science, which will result in the cost reduction and make the product more efficient and make the customer being more benefited with the product. Okay, so these are all the key benefits that we are gaining from data science. Okay, so it becomes an absolute necessary for each and every company to have a data science team that is going to drive the next generation product. Does that make sense? Now I think you can understand why companies require data science team. Guys, are we clear with that? Any questions? And there are a lot of requirements which are coming up, like data science, which with a subject like data science. So there are a lot of blogs, you can see a lot of requirements, lot of blogs, lot of talks, lot of discussion which are going on around data science. So that is the key thing for the next generation. So you will be see a lot of jobs, lot of openings. Companies are going to focus more, and they have more investment on doing data analysis, because that is driving their product. Okay, so what are all the key benefits that we are gaining from the data science? Let me put that. Let me clear this. Okay, so guys, any idea, can you tell me what are all the benefits that we can gain from data science? So I think you can list out the key points that we have discussed already. From that you can list out what are the key benefits that we can get from the data.
Reduction.
Yeah, the first one is
In cost.
cost reduction, right?
Yeah.
What else?
Decision making.
We can say
Of course.
faster decision making.
Faster
Faster,
decision making.
faster and better.
Yeah.
Correct? What else?
Based on current data, predictive intelligence or predictive analysis.
What we are going to gain from the predictive analysis and the data analytics. So we can bring next generation better next generation product, correct?
Yeah.
What else? We can provide improved service and product, correct? Clear? So these are the benefit that we are going to gain from the data science. Clear? Any questions? Guys, these are very important things that we are discussing, because which will help you think why we need data science, why companies are investing more on data science. Okay, perfect. So next we are going to talk about what is data science. So I think the we have the data science word, which was talked and which was brainstormed in the last few years or few months, right? Which emerged very recently. Okay, and that comes with two key things. One is mathematical statistics and data analysis. So these are the two key components that is driving the data science. One is mathematical statistics, and the other one was data analysis. Okay, the journey was too long, and it was really amazing. There are a lot of improvements and a lot of benefits that's being gained by the company, right? And they have accomplished a lot of stuff using the data science field in the enterprise. Okay, and in the next few years, we are going to, we'll be predicting the future is going to be climbed. They are saying that each and every company is going to reach a milestone in predicting the future, because you can think about the another example. If you take an example of Walmart, so they are selling, even you can take Amazon, so they are like retail, right? Retail, they are providing retail service to the customers. So say for example, if it is a December, if like every month they have some historical data point what they sold more. So based on that, every year they can stock the product, right? Because say for example, in the month of December, it's Christmas Eve we have in that month on that particular day. So that is going to be a lot of sales, which will be more on cakes or gifts or like that. So we need historical data points, what customer have purchased more in the last year. So based on that, this year I can stock those product in a large volume, so that we will not disappoint customer and we will make more business, right? Because if you are not having enough stock, then customer will not able to buy. That will directly impact the enterprise benefit, like enterprise uh, gain, right? So with the data science, what we can do is we can easily predict, okay, last year, from the last 100 years, in the month of December, on the day of 24th, this product is sold this much, but we are not able to get this many stocks. Because of that, customer was not able to purchase this. So based on this 100-year data, so we can have a better decision making stuff. With that, we can stock the required product in the shop. That will benefit the organization gain. Does that make sense, guys? Can you able to follow me? Guys, sorry there.
Yeah. A quick question on that, Kondaswamy. Let's assume the statistical data itself can be deceiving sometimes. Basically, the data of data means if I'm taking 20 years back Christmas analysis, that may not be valid after 10 years, because the trends have changed after 10 years, let's assume, and you are still depending upon 100 years of data or n number of years of data, then the decision making may be wrong, right? How do you plot, how do you take a better decision on statistical data? How many years of data to be taken in order to make sure that your judgment won't go wrong?
Correct. So that is a great question, actually. So let's talk about more specific stuff. Okay, let's take an example of a specific state. Let's take Seattle, Washington. Okay, let's take a particular city, Seattle in Washington, and we have a shop called as we have a shop for Walmart, right? So for the last 100 years, let's say the sales report for the month of December and for the day 25th. Okay, so you have the data value, correct? Which product has been sold more, correct?
Yeah.
Shama, can you able to follow me? And
Yeah.
we have a population for that particular city, correct?
Mm-hmm.
So every year there would be a population count for that particular city. So what we will do is we will combine these two results. Every year, what is the population, how much this was sold. So like that, we will be getting a data points. Like say for example, in 1980, so this is the population, this is what the product that was sold on that particular day. And 1990, this is the purchase on this particular product for this particular year, for this particular city. And this year, this is the current population. So if this is the current population, based on this data point, what would be the predicted sale? Does that make sense?
My only question is the dependencies, the variances that are occurring within that data point, like the external factors for that point may be varying, right? Like the average earning of the persons or the daily wages
Correct,
are
correct.
going up. Anything may impact the statistical data or the output of the data, right? So the variance is adding that variance and removing the variance, the plotting itself gets differed. Make sense?
Correct. Yeah, definitely. I'm totally with you. Not only, see, there are different parameters. So we are talking about only 3 key points, right? One is product sold and every year, and what is the population. There are different parameters on top of this. One is what is the wage rate for each and every year that is going to impact, and what is the current say for example, even there might be a possibility there might be a bad weather condition, so people will not come to the store. That is also that is also a possible factor, right? And there are different factors that will be taken into consideration. But see, these are, kind of predictive analysis, and we cannot say 100% this is going to be correct, because there are a lot of unfortunate things that may happen that may not be considered when we are doing the data analysis, right? So this is more like we can consider the maximum factors that has been, say for example, you can take one thing, say for example, in the last 100 years, there might be an impact that might be happened. Say, for example, the salary wage might be went down, and there might be a bad weather condition happened on that day. So we have that data point also considered when we are doing this data analysis and predictive analysis. Does that make sense?
Yeah.
Because we have all the historical data points stored in the enterprise database. So we're not only capturing what is the product that is being sold on that particular day. We are capturing the population. We are capturing the wage. We are capturing the weather. We are capturing these holidays. So all those stuff.
One more question added to this is, let's assume you are having so much of data on the storage, and you are keeping that data in order to have that analysis, right? The cost impact of the storage itself will be more. So at one point of time, okay, enough is enough, I'm going to throw away this data. You need to decide that also. Otherwise, the problem of storing the data related to the data itself is increasing, right? So instead of only have the data points rather than having the data itself, right? That decision also need to be taken at given point, given date, right? Make sense?
That's right. Yeah, that's right. Yeah. That is, I'm going to talk, I'm just giving a high level key points now, but we are going to talk more in detail about all these factors.
Okay, thanks.
Guys, give me a second. Guys, can you hear me?
Yes.
Okay, sorry. I took some water. Okay, so coming back, so we are talking about data science. The data science is more like data-driven science, okay, which makes use of scientific methods, process, and system to extract knowledge or insight from the data in various forms. It could be in a structured or a non-structured. So we can say data science is a data-driven science, which is going to make use of these scientific methods, process, and system to extract knowledge or insight from the historical data, which we have it in different forms, which could be a structured data, semi-structured data, or unstructured data. Clear? Are we able to understand what is data science now? So we talked about two things. One is why we need data science, and second one is what is data science, right? Guys, are we clear? Okay. So next we are going to talk about who is data scientist. Any idea who is data scientist? Any guess? Guys, you are going to be the data scientist after this program, right? So tell me, who is the data scientist as per your understanding? Okay, sorry there.
What is your question, Kamisan?
So the question is, who is data scientist? What are the key knowledge that he is supposed to have to become a data scientist? Because we are going to be the data scientist after this program, right?
No, the guy who takes care of the data and manipulate the data in use of business intelligence and mathematical modeling to arrive at intelligent decisions, I guess.
Yeah, so let me give the clear idea who we can call it as a data science. Okay, so data scientist is nothing but nothing like he is going to be a master of all the trades. Okay, he should be proficient in maths. Okay, and he should have a knowledge in the business field, and he should have a good computer skills as well. Okay, so he is like a all in all, we can say. So he should be efficient and proficient in maths, and he should aware about the business knowledge, and he should have a computer science knowledge too. Okay, so this combined skill person, we can call it as a data scientist. Clear? When we are talking about maths, so the data scientist should have knowledge in especially from maths perspective, he should have knowledge in statistics, discrete maths and information theory, combinatorics, decision theory, and machine learning from maths. Okay, so I will repeat it: statistics, discrete maths, information theory, combinatorics, decision theory, and machine learning. Okay, and from information systems, so he need to be basically he is a computer science engineer. Okay, he is from a computer science background. And then the intersection point between the maths and the information system, so that's what I told, right? He is from a computer science background, so the intersection point between the maths and the information system is data visualization builder. So using his maths capability and information system capability, he should be able to build data visualization, and then he can do a statistical program. Okay, so he need to combine both this maths skill set and information system skill set, and he would be able to build data visualization and statistical programming. Okay, on the other end, he should aware about business, right? So business in the sense, he should have knowledge on economics, finance, marketing, operations, and management. And the intersection point, see, there are three things I'm talking about, right? Max, information system, and then business, correct? So when I'm talking about max, statistics, and then discrete max, combinatorics, and then decision theory, machine learning. From information, so he should have computer science knowledge, programming knowledge, we can say. From a business perspective, she should have knowledge on economics, finance, marketing, and operations management. So using this max and information, I can put here max and information system. What he will do is he will build data visualizations, and then he will do statistical programs. Okay, and using max and business, he will do econometricians and management. Oh, it's not visible. I can put MGMT management, scientist, and accuracies. Accuracies. Okay, so with max and information system, he will do this, and using max and business, he will do this, and using information system and business, he can able to build business intelligence development and then data analysis. So the intersection point, the business, let me find that. The intersection point of business and information system and max is going to be the data scientist. Clear? Guys, any questions?
I have a question here.
Mm-hmm.
So all these areas looks like they're all like major areas. So would somebody know all this, or because math and statistics itself is a big area, and then business looks like a different area, and information systems is a different area. So is that because mostly like computer science people, maybe they don't have knowledge of economics or finance, or some people don't know stats. So is that something that people need to learn to be a data scientist?
Yeah, so let me take an example of myself. So typically we are from max background, so we should have knowledge on max, not in a like we may have like if we are from engineering background, maybe we may have little bit stuff covered on statistics, discrete math, and combinatorics and decision theory, of course machine learning. So but we have some idea, based on that we can build our skill set on the max, right? But I would not say we have
Right.
We are all expert on this area, but we have basics built on us. So based on that we can build our skill set on these areas, right?
Right.
And
I mean, I don't think anybody would have a deep knowledge in that,
yeah.
because some people wouldn't have studied any mathematics related subjects, let's say after high school, right? So it's I mean, I think it depends on like individual, but if it is something that people can pick it up, then I think that's actually good.
Yeah, definitely. But see, like before, see, after this program, we are going to call ourselves as a data scientist, right? But we should know who is data scientist. If someone asks, hey, who is data science? I want to understand. Then we should know what is data science. That's why I'm just trying to cover it, because some of the people, even they are in a data science profile, but they may not like understand what would be the exact role. That's why I'm trying to cover what are the key skills and what is the intersection point that makes a data scientist.
Okay, got it. Yeah.